particularly on application of IoT in irrigation system, and that was on the basis of the moisture content in the field, and that monitors the moisture content. And now with IoT, we are also integrating AI, so that also monitors the weather also, and then it gives the message that what is the right time to irrigate in that particular crop. And that lot of efforts are being made, not only at our institute but also at Audi, as well as at IIT Kharagpur and other institutes also. And even now, even some farmers have also started adopting such irrigation system, particularly in the state of Maharashtra. So in robotics, we are developing not only Vida but also Maharashtra, also at our institute we have made attempt to develop the automatic feeder, so that can be remotely controlled. Next. For spraying also, we have made attempt to develop the electrostatic sprayer at our institute. Right now we are making a slide, and that we have tested for parking loss. We at our institute we have also developed the uniform grade spraying systems. Because for example, we have to apply a particular rate of pesticides in the field, and whenever there is variation in forward speed of tractor, it varies the total application rate of that particular chemicals. So it monitors the forward speed of the tractor, and on that basis it gives the signals to the solar and was proportional to that, and then it regulates the application rates, and so uniform rate of spraying can be made. Another number of institutes like ultrasonic sensor-based spraying system have been developed, which identify the canopy and then displaying only on the canopy, particularly performing their unit crop, and that requires number of spraying of more than 10. In addition to that, right now at our institute as well as a few more institutes, canopy based kind of assessment of canopy volume, and on that basis it varies the spraying rate. And now remote control spares have also been developed, and they identify the particular location, and right now efforts are there that those sprayer may be able to identify the infestation of the pest and then we may be able to go for target spraying, not only by remote control spares but also by drones also, in that also efforts are being made. Next. So for the identification, we have used the heat-based algorithm, and then we were able to identify the heat also as well as the heat also, and then we are going for target feeding or target spraying. So initially I was talking that we have developed a device for identification of nitrogen stress, and now we have integrated that with variable rate applicator also. So in that we have developed the NASAT type variable rate applicator. So in that image is taken, and that image is analyzed in real time. In real time, there is the application rate of liquid urea, and we have also developed granular fertilizer applicator at our institute. Right now that is under long duration time. At our institute, particularly in the greenhouses, if you go for a spraying, if someone sprays chemicals, and it is that just for a personal motion or that, but we have developed the automatic spraying system for polyhexid also, and that moves on the leaves the way tails moves. So we have also provided the tracks, and on that basis, on that moves automatically. It also identifies the area of that plant, and then is spraying on the other plant. In the area of harvesting, efforts are being made at our institute, particularly for development of yield monitor, and that is in the advanced stage. In other countries, we may have even observed that yield monitors are part of combined harvester, but in India, yield monitors are not combined. In addition to that, at our institute, we have try to estimate yield of orange orchards, particularly using taking images, using drones and then analyzing it, and we have got the accuracy of 84%. Particularly for harvesting of fruits, etc. Everybody talking, particularly in developing countries, that we have to go for use of like robotic harvest of apple, etc. But in India, I think we may not use robotic harvesting of tomato or chili, but we may use robotic harvesting of coconut, black pepper, which are difficult to do it with mechanical sources. In our country also, automatic tractors or autonomous tractors have been developed. Even Mahindra had introduced in 2019, but that had not popularized, and now they have stopped production of that also. But we have developed the remote control unit, particularly for operation of power tiller as well as rice transplant. And right now we are in the process of commercialization of that control unit. So it can be operated from one corner of the field, so it reduces utilization, particularly for operation of power tiller. Next. Nowadays, government is putting a lot of focus on use of tools in agriculture. So particularly government focus right now is permission of drone for use of spraying operation as well as for nutrient application. We have tested drones for use of like fertilizer broadcasting also, seed broadcasting also, particularly of green manure crops, as well as yield estimation of fruits also, and irrigation scheduling also based on the taking the image also. So in the future we are expecting that drone will be used for a number of applications, number of operations in crop cultivation, and right now we are in the process of developing protocols, standard operating procedures for different crops, for different operations. Also in that number of active centers are working in that. So particularly what is expected in future, and I have been given title that I have to collect for future also. So by 2047, in the initial also I have mentioned that around 26% of our workforce will be engaged in agriculture, and that also major contribution will be of female workers, of female entrepreneurs. So in future we are expecting that farmers will be looking for custom service, particularly for to carry out different operations, because land available with them will be very limited. They may like to just make a crop, and the service provider may need to their field and carry out that particular operations. Another availability of data will be there. So farmers will be able to take smart decisions and what will be the right time to carry out a particular operation that will not only enhance their productivity but also reduce the cost of cultivation also. Another, whatever machinery will be there, it is expected that number of machinery will be limited, but they will be multi-purpose. Maybe in the position to just removing one attachment by another attachment, maybe in the position to carry out different operations. New type of material will be there, those may be lighter, having better strength, particularly for using pharmaceutical development also next. So here, again, irrigation is there. I have already mentioned that these area will be like we have to use data, and that data has to be analyzed. On that basis, we have to take smart decisions. But what I envisage, there will be very fast changes in the way technologies are being developed. If you heard about software industry also, now they are talking about long-term technologies. In agriculture also, a few years back, we were not even thinking about use of drones. during last 4 or 5 years, everyone is talking about use of drones. So that there will be fast development in this area also, and we are expected to be updated also. Next, particularly autonomous vehicles, or autonomous tractors, or autonomous transporters, or power dealers also. We may not see 100% use in Indian agriculture, but some autonomous village will be there. They may carry out some operations which are difficult to carry out on the. So in the end, I would like to highlight that cost of input is increasing, and we have to develop machinery which apply inputs as per the need at the right time, so we may have the better yield from different crops. Another, right now, a lot of efforts are being made for development of smart machinery. Those machinery need to be reliable, those machinery need to be affordable, otherwise farmers may not be interested to use them. Another, we should not work in isolation. Yesterday also there were a lot of academic industry interaction, collaboration, but in that still we are lagging behind. Right now, particularly for development of smart machinery, industry is also working. And sometimes it is happening that same kind of research is being done not only in ISCAR Institute but as well as in industry, and sometimes industry is ahead of us. So we should work together. We should identify the problem, join hands based on strength, and work together. So we will get better output in that short time, and that technology may also commercialize at faster pace. So this is all in brief about my presentation. Now we can have questions. Any question? Because my talk is I have shown some technology. I haven't gone in detail of the technology. Just my purpose was to give you an idea about the kind of research being done in our country and what is expected in this area. Yeah, we can put on mic.
One is regarding the develop the stair, identify the nitrogen stress, we formulate the process as per the stress. It is crop specific or it is generalized for all crop?
No, it is crop specific. We have tested it for rice and wheat only. My colleague Dr. Chandan here, he is working in that area, so you can discuss with him also. But we have to first conduct experiment with different dosage of the nitrogen for a particular crop, and then may also be for a particular variety of crop also.
Another is regarding the drone, sir. In case of large area, we can go for drone, but in case of small area, it may be problem for another crop. Most of the farmers go for integrated farming system, and then that time what we have to do, or whether it is any protocol for use that drone.
Actually, right now I have mentioned that we are in the process of developing protocol for number of operations, number of crops also, and particularly you are talking about the intercropping. In general, it is expected that particularly in long area, the fields may be of different owners, but same type of crop may be grown, and in that case we may use drones. Similar system is there in China also. If you see the average land opening there, that is even less than in India. But their government instructs farmers to grow a particular crop in a particular season in the wheat, so different operations can be mechanized.
As you said, the drones approach here are the governments are taking as it is just taking isn't actually doing proper research on it. Especially my this thing is even the farmers are using for spraying the herbicides. That is the wonder of it, and even I so many forums I could resist. So you please do it for some pesticide, it's okay. But you are going for a herbicide, it is banned for even US. They are doing some US based this thing and all. Say how best we can do some research on that.
Actually, government has started this scheme at very fast pace. So initially we were not having even normal protocol also. So that was also prepared in test. And that was not prepared for early crops in that even where we were university had taken the lead also. Because you have come up with number of protocol and number of crops also. So that's why right now we are working on that, developing the standard protocol not only for spraying of pesticides but also herbicide also at our center located at and they have conducted some study of herbicide application with the use of drones. So actually we have to come up with the protocol and then we have to use drones particularly at farmers. Otherwise farmers if they do not get good results they will not be interested. Right now, government is giving subsidy for carrying out the spraying operations, even for use of fertilizer also, our colleagues are also working in that area. So, we have to come up with the standard protocol as soon as possible, and that protocol area.
If no more questions, thank you, Dr. Mehta, for giving us a clear picture of mechanization. Mechanization different crops, and then the future trends, different approaches to be made, and the things which are developed by say global and the regional stations. Thank you very much for giving us this.
Thank you.
Presentation.
So, I think
Because for any postal procedures are there, please display your process outside, the process of the process, please.
So I think there will be more presentation as well during my presentation. Who are going supposed to make presentation in this session? Is there any? I think we have six or seven presentation more. So I request everyone to take around 10 minutes. Earlier I had spoken 15 minutes. But now I am sure I have also taken a little bit longer. So 10 minutes for presentation or 2 or 3 minutes for discussion, not more. Next presenter is Satish. And he will be presenting on study on energy utilization pattern for small farm mechanization.
नहीं सर मेरा था एसी का हमारे
Today's presentation is on energy research for small farm mechanization. And as you know that it's a very important area, particularly for small and marginal farmers. Here, we perform whatever different operations, right from primary village to up to harvesting of the crop with the help of different machineries, and those machineries operated with different prime movers and single operation, and most of the time single operation by single you can say power source. So we the initial phase of my particularly DSC project, we analyze this energy utilization pattern for different power sources and different operations, and then based on that some observations we made, and we planned for our design and development of the providing work for particular operations. So that particular thing I am going to present. Here, if you see that for particularly this overview of RTH, not many options are already available in the market. Right from, if you see the first one environment, there are so many, but if you see the status or the economic status of a small farms or the farmers who have very less land, then it is sometimes that particular machine for a single operation is not offered. So we try to identify different power sources, and according to in what way they consume the power and how much based on the energy requirement and working hours, we estimated the energy utilization of different operations. So for sowing, spraying, then harvesting and diesel. And based on these selected operations, we modified the design so that we can perform these operations by a single power source, and it should be in an economical way. So based on both different power sources and operations, if you see that for rotary village, if you perform it with the help of mini tractor, the energy utilization factor per hectare, it varies from 822.70 to it goes up to 1000. And for different, and particularly these kind of operations are very much energy intensive, like this reach or from making. These two operations are, but if you want to develop a system, then we have to incorporate right from a less energy utilized operation, and that up to go up to the higher energy utilization. So these are the major options that most of the things that is high initial cost of prime works, either say pocket walk behind type or riding back even. With one or two component operations like this energy, this mobility and some operations like for and which are actually uneconomical for small and marginal cost. And sometimes these small prime works with whatever these are having very poor traction. Why? Because sometimes the industry or some local manufacturers, they just try to scale it down with respect to the size of the machine, and they never bother about what exactly happening and whether these machines are really efficient for performing that rotary village operation or whatever operation is there, and they just put it in front of the farmer, and those machines are not actually useful for them and are not even efficient. So based on that, so we finalize that the diesel operated system that should be in our prime mover, so that we can use it for and we call it utility prime mover. Then single chassis for front and rear mounted equipment, and because some operations we need to perform like this reaper, we need to mount it in front of the prime mover. So that attachment and that power system we try to develop in our prime mover, and this particular target we have set for us that it should be a riding type, so that although we always focus on riding the type for a farmer, so that riding type of prime mover, and it should be economical. So what I present that it should be less than 1.5 lakh with at least 3 operations where we can perform with the help of this way. So with this I stop my presentation. Thank you.
Okay, thank you. Any query? One or two questions you can take. First was a recent
Just after improvement. Yeah. Overall rotating kind of thing, but there is a huge difference in energy utilization.
Yes.
Why this kind of thing?
Because these small rotary tippers, they are self-propelled and like this tiny. They are having very like this 1.5 HP power sources. So ultimately that will give the lesser, you can say the. But if you operate with the this high HP and the rotor like this, so that ultimately having the.
It depends on the energy utilization and depends on the field capacity.
Yes, that is
It will be smaller or large, but it will be tiny will be probably same. Electrical probably same. It probably same, and if you find a exact teeth condition probably then probably exact operation pattern may be same, maybe little difference, but there is a difference. It will be going to 170.
Yeah. And that's
Sir,
not that much action.
actually the power tiller are very well designed equipment for Indian condition or Japanese.
No,
But these other things are just what you call assembled
They just
or
do it, but
done, not really properly designed those.
These are not properly managed.
Yes,
That is the reason why it's getting.
yes.
The tractor is able to pull, but the tank is
May not
able
be
to
able
do it.
May not
That's
able
not
to do it.
sufficient.
Yes, yes.
That's why so consumption is more important or consumption is
Satish, I have some basic questions. One is that you have mentioned field capacity in answer.
Yeah.
Unit of that is hour per minute. Is it correct?
To read that.
That is time requirement for an actual
Yeah.
reverse reciprocal of field capacity.
Yes, sir.
And how can you calculate this energy requirement?
So basically the energy requirements, how much fuel consumption will be there, number of masses, energy coefficient is also there. So based on that, we
You have taken into consideration direct and indirect energy, for example, energy required to the manufacture that machinery, as well as
just
fuel
for
consumption.
performing that particular operation, not the whole.
And that is not complete energy.
Yeah, that we can do.
Okay, thank you. So next potential is energy lemon supply.
Good morning. I will talk about this presentation on drafting and sales versus the power because the two most important power sources which are common is for mechanization is the tractor and the power tiller. But the limitation of power tiller, if you look, the annual use is only 300 hours as compared to 1000 hours in case of tractor. The reason is unsuitable for primary village operations, low draft and roller power limit. The use of power tiller for pulling of small size implements. The lesser weight of power tiller and use of small size pneumatic tools. These are the limitations for which the annual use hours for power tiller is only 300 hours. So how to improve it? There are few researchers who have already conducted some study, and what they observed is if you look at the capacity. The unit capacity is 6.75 kilowatt, whereas dropper power only you are getting 2.89 kilowatt. You can see the difference. Just now, my previous speaker, he told the power requirements. So this is the reason. So you are only utilizing 2.89 kilowatt, whereas in tractor the power availability is much more, and you are not utilizing fully. So anyway, now how to improve this? In traction studies, this is the basic governing equation. Thrust is equal to, this is the maximum thrust I am talking about, AC plus W times phi. For a given solid condition, there are two parameters. One is the contact area, A and W. These are the two parameters which are going to improve the practicability of any particular machine. Now, when I am talking about these two machines and the reference to power tiller, if you want to increase the weight, you are unnecessarily increasing the rolling resistance. So the only option left is contact area. So if you can increase the contact area, then only you can improve the tractability of power tiller, so that more tools are available and you can utilize many more implements so that its harmonics can be improved. That is the concept. Now, how to increase the contact area? There are different ways. The best way is replace the wheel with the bigger wheels. Just like in tractors nowadays. Earlier it was 12.4, 28 tires are common. Now they have shifted it to 13.6. Now 16.9, 28. So we cannot do that here. When we try to put a bigger wheel, obviously the entire thing will be lifted. And you need more moments. When you try to pull some implement, more moments will be active. So the design problems will be there. So how to overcome that? The best way is put a truck. Truck, we are not going to disturb the entire system. The height, everything will be remaining same. Only we are increasing the contact length so that, as you know, the governing equation is AC plus W tan phi. So A you are increasing, so you will be getting the more benefit in terms of code. So with that concept we try to develop. So this is the locks which we selected is similar to the locks which are provided in power tiller wheels. And only the length we have increased. So for that what I have done is we have replaced these wheels, the power tiller wheels, and provided a ring with the bar so that a belt can be pulled around over this wheel, and there is an idler in the front. So this is powered, this is unpowered, and there are tensioners in the bottom to show that the contact area is almost flat while operating in the field. So these are some of the arrangements which we made so that it can simply follow the undulations provided in the field. So the total specification is like this. Width of the truck bed was 0.15 meter. Then contact length was 0.78 meter. Diameter of the front idler 0.34 meter. Diameter of the rear drive is 0.55 meter. Now each of the locks is 80 millimeter. Now as compared to the wheel size, you can see this is only 152.4. So contact length is increased. Now the belt the trap which you have developed just locks on the outer side as well as the inner side. The inner side locks are provided to give proper grip between the power wheel and the belt, and the outer side locks are provided for steering action so that you can develop necessary power from the soil. So once you develop, then you want to test it in terms of how much power it can develop and what is the practical efficiency. So all those parameters are related to sleep. So these are the parameters we are trying to study. For this, we would try to instrument the power tiller. For measuring sleep, we took the power fifth wheel and a proximity sensor. So proximity sensor which is mounted here as well as in this wheel. So this will give you the actual, the theoretical speed, and this fifth will give you the actual speed. So once you know the actual speed and theoretical speed, you can calculate the slip. Then for measuring pull, we use a load cell of 2000 kg capacity, and it is mounted on the back side of the power tiller, and then the power tiller was used to pull a tractor. Initially the speed of power tiller and tractor they are kept same. Then you try to reduce the speed of the tractor so that gradually you can give load. And the corresponding speed per meter. So this is the total scenario of the experimental plan. Then this is the soil condition where we try to test it. Sandy clay soil and 3 different quantities values, average quantity values, 250, 500,000. Then these are the sand sheet clay percentage. This is how we measure. For measuring only resistance, we keep the power tiller at the back side of the tractor and the tractor is used to pull it, and in between there is a road shape that will give you